Hi there, welcome back. Welcome back to another video in the restoration series of the Grundig Satellit 650 Pro. Fair warning, this video is about frustration. It's about frustration that results from not being able to figure out what it is that you're doing wrong. It's frustration that results from knowing that whatever you're dealing with is actually quite simple, but you're just not seeing it for some reason. And it's also frustration because for you, when you see me doing what I'm doing and you know the answer and you wonder why I'm taking so bloody long to figure it out, that's frustrating. So if you want to join me in the frustration, stick around. But let me just tell you briefly what this is about. I had a problem with the audio selection here. When I selected AM bands, the audio was fine. When I selected FM, I got audio. Then I realized this audio is actually very, very low compared to the maximum volume that this thing's supposed to produce. It was very clear, but it was very, very low. When I selected the external input, I had almost no signal going through. And there was another problem. I was getting about 6-7 volts DC feeding back into the audio input, which is not a good thing, as you can imagine. So there was definitely something wrong. I was trying to figure it out. I was trying to read the schematics. I wasn't reading them properly. I had to look for different schematics. People helped me get alternatives and things finally became clear. But that's it. This was about the audio selector and the mute function that was activating when it shouldn't. So as the title says, mute left me speechless for about a week. That's why it's taken so long to do so little on this radio. Anyway, if you enjoy frustration, watching me go through mine, stick around, enjoy the video. What you see here is the result of almost a week of really frustrating diagnostics going on here, fault finding, trying to trace a problem that I discovered when I did the audio input check. In other words, when I put a signal into the external input and try to get this tone coming out the other end. Obviously, that's part of the amplifier test section, which is usually one of the first tests that I need to do. And I was finding that it was not working as I expected. I would put in a signal here, and what I was getting coming out the other side was an extremely low-level signal. Then I found something else as well. I found that the FM, while it was actually working very, very low. In other words, at a very, very low level. Let me show you. I've got it on FM at the moment. I've got almost no antenna on, but everything's working fine, right? That is maximum volume. Now that definitely doesn't sound right. So what I decided to do, obviously, is follow the signals. And the signals are all selected at a particular spot over here, which is there. That IC, which is IC601, is responsible for acting as the switch between all the audio sources. So what sources do we have? We've got the audio input from the back here, from that point over here. We've got FM, we've got the AM bands, and that all gets selected over here. When you push those buttons at the front here, that is what activates whichever input is going to go through to your preamplifier section and then get amplified as audio. So I went and checked over here, and then I found something really weird. Let me show you that. I went and looked at the output of the switch. So this IC, which is a quad switch, switches between one of 3 inputs. So it'll switch between AM, FM, and the TA input over here. And the output is at this transistor over here. There's a test point, which is test point 601. And I put the multimeter on there. So that is the output of the audio. And it's giving me 8 volts, which is rather odd for an audio output. But let me go to, this is my, I've selected TA, in other words, external input at the front there. I've got 8.41. I'll select long wave. It starts off at a fairly high DC voltage, then it goes down to close to 0, which is where it should be for an audio signal. There it goes again. I've selected medium wave. I'm going to go for short wave now. High voltage, and then it goes down. And FM. high voltage, and it stays there. That I found was rather strange, especially because the AM bands, I'll go to shortwave again, AM, whether it's shortwave, medium wave, or long wave, the audio level was fine. It was the TA, or the external input, that one there, which was staying at a high voltage, that was giving me a very low level, and also FM, which is that one there, that was staying at a high level, which was also giving me a fairly low level. So something was wrong with this point over here. And this point over here is the result of various things. It's got the output from this chip, which is a CD14066. The outputs of that go to there, but also the mute switch, the mute function on this radio. There are various mute functions on here, which I'll show you on the schematic. They all activate that transistor, which then results in whatever's coming out here. And I'll show you just very quickly. If I select one of the AM bands, you see it goes down. But if I hold the button in, it stays at a high voltage. So that's telling me that when that is at a high voltage, we've got mute activated. I let it go, and it's gone down to fairly low voltage. Let me try medium wave. If I hold it in, it stays high, and then it goes down. I'll do shortwave, but I won't hold it in. I'll just let it go. But as you can see, it'll go up, and then it goes down. So what's happening is when you select the frontier, one of the sources of the frontier, there is a mute signal going to that transistor, which then forces the transistor to make this level high and therefore mute the signal. Also, there's something else. And this I've got to show you so that you understand how this mute function works. I've got it on one of the AM bands, and I'm going to spin the tuning dial fast. See that? And then it stops and goes down. So if I spin the dial, it then goes down. So what's happening is when I'm spinning the dial, it actually mutes the audio. So this must now be the microprocessor operating. Got that working. The microprocessor is sending a mute signal as well. So we've got various things happening here that are activating mute. One of them has got to do with the switches at the front here, and the other one has got to do with the microprocessor itself, which mutes the audio when you are fast tuning, and then when you stop tuning, it brings the audio back. That's for the AM bands, obviously. So I couldn't understand what was going on here, and I had to sort of find out what was going on here on the schematic before I could figure out what to do at this stage of the circuit. I did a lot of stuff. As you can see, this thing is now on a socket because I removed the chip, but I've put the same chip back. That's why you're getting the same results. But let me show you on the schematic what the hell it is we're talking about and why it was so confusing. Right, so here we've got the selector section and the mute function all in this part of the schematic. And it should be quite easy. It actually is quite easy because if you look at this IC here, it's an MC14066. It's a CMOS quad switch, which is activated with a high signal. Now, what does that mean? Well, it's got 4 independent bilateral switches. Here's 1, 2, 3, and 4. Now these switches, let's look at this one, has got the 2 contacts of the switch, and there's this thing over here which is connected to the one part of the switch, which goes to another pin. Now what does this mean? Well, what this means is, and the way this IC works, is whatever you want to switch, this is a normal switch. Imagine you've got a normal on-off switch, okay? It's normally off. When you supply a voltage, a positive voltage, close to the supply voltage, it makes the switch. So if this switch is open, this signal is not getting to the bottom here. But if I apply 7, 8, 9 volts over here, this switch closes, boom, and then that goes through, and this path is now a continuous path. And that makes sense. That's a normal selector switch for various channels. And let's look at it. We've got this one here, and we know that this activation signal is for FM. So our FM comes from the FM detector, and it waits here until you send it a signal to say that it now has to pass FM through. And it passes this from pin 4 to pin 3. On this one here, we know this is the AM, so the AM signals, whether it be from long wave, medium wave, or short wave, that you select somewhere else, they come out here. They are here waiting to be switched through, like a normal selector switch. And when you send a signal to say that you want to listen to one of the AM bands, boom, that goes high, and that switch is made. Obviously, if that switch is made, that one is now open. So the FM is not getting through. The AM gets through to this point here, which happens to be connected basically in tandem with this other one that you had from the FM. And this is another one here. This says auxiliary. So this is our external signal. When our external signal is pressed, when we select external signal, this voltage here, 8.1 volts, is applied to this, and whatever is on here goes through to there, and therefore to this bus over here, which is receiving the selected audio. Now, what is this one over here? Well, if we follow this one back, it comes to our RCA socket over there, which is the one we used to feed a signal in at the back. And it also comes from the pin 3 and 5 of this DIN connector. It says here 3, 5, and 2. 2 is ground. 3, 5, and 2 is playback. So it comes from there or from there. There's a ground reference resistor over here of 100K, and that audio signal is fed into there. You select TA or X auxiliary input, and that gets through to this point. So this is our audio out from the selected function. So what the hell is this doing here? And I've got to tell you, I feel really stupid. Not the first time, not the last time. This transistor is NPN. This radio is not a positive ground radio. So I did not expect to see a transistor here with its collector connected to ground. If you know a bit about transistors, or a little bit as much as I do, you'll understand why that is a bit strange. If you know a lot about transistors, this will seem obvious to you. But anyway, that confused me. So this transistor over here then meets this point here. And this point here has just got a 10K resistor between these audio collectors over here, right? It's collected the audio, goes through a 10K resistor to this point, can't go back down here unless this one is shorted to ground, okay? So it has to go that way, and that way, 0.38, if you follow the signal, it goes to the preamp section, okay? So this, and because it says mute, must be the mute circuit. And how does the mute circuit work? Well, this is where figuring this out became a little bit complicated. This line that goes back here goes to the on-off switch, and it actually activates this transistor. We'll forget about that one for now. This signal that actually switches on this transistor is over here. And this signal, according to what I've been able to read, is obviously the mute switch or the mute function. And the way the mute function works, there's actually various ways it works, but one of them is this signal over here. This is 8.1 volts. We can see that it's actually from the supply line. But this is going to this other switch over here, one pole of this switch. Now, what activates it? Well, what activates it is this signal over here. And this signal comes from the microprocessor. And the microprocessor sends a activate switch signal, rather, to this switch when you are spinning that dial. In other words, when the microprocessor decides that you're tuning too fast, you don't want to hear all the crackle, you want silence. So it sends a signal and says, shut up for a while. And that activates this and sends 8.1 volts down here, blah, 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 out of this section over here. That goes high and switches on this transistor, which activates the mute. Now there's another switch over here, which is a bit strange. And that is this one over here. This is what really got me. You see, this here says stumm. Stumm means mute. That makes sense. All it is a supply line, right, which is switched to this point, which sends a positive signal, 8 volts to here, which should activate the mute function. That makes sense. It should activate the mute function. However, if this thing is on all the time, then this should always be on all the time. So this confused the hell out of me. There's also a capacitor here, and the idea is that when you deactivate mute, because of the RC time constant of this capacitor, and I think it's this resistor, it takes according to the information, about 150 milliseconds for the mute to drop out. So I got confused here, and I couldn't figure out whether the problem was the switch, whether it was one of these capacitors, whether it was this transistor. I took out this transistor, and of course, none of the mutings were operating because there's no transistor. But that doesn't tell me where the problem came from because the transistor measured fine. So I came to the conclusion that it had to be this chip. And I think that conclusion is correct. And that's why I finally desoldered this bloody thing and put a socket in there, and I'm waiting for these things to arrive. But the reason I got really confused with this switch is because this is not the position that it's normally in. I'll show you where the switch is. If you look at the switching diagram, here is STUM. But STUM is not there. You know, you've got auxiliary, long wave, medium wave, short wave. There is no button called STUM. And then I realized that what STUM is a mechanical switch that makes anytime you push one of these, okay? Whenever you push one of these guys, STUM makes, but it's normally open. This thing is normally open. That was what really confused me. And this switch is actually on the switching bank that's on that board at the top there. You can see it. If you look down from the top, you can actually see it. These two pins stick out the top, but it's not a switch that's got a button to the front. That's where I got confused. And of course, it's normally open, not according to what the schematic shows you. You see, what the schematic shows us is that this thing is normally closed, which is wrong. Oy. And how did I figure this out? Well, with a lot of help from my friends. I got hold of Derek. We chatted about this. And while we were speaking and I was plotting around, it sort of started making sense. So let me show you where else I got this information from. This is where getting a lot of schematics helps. A viewer pointed me in this direction to this document. Now this document is related to the 600, whatever this means, but it's for the Satellite 600, and it's a technical description on how this thing works. And here, this is where they describe the mute function. They show us how this works. They tell us that this is from the microprocessor, and the microprocessor sends a signal, and then the resistor capacitor time constant keeps it on for a while. This is the one that really gave me a clue. But then there's also the schematic for the 600. And this document does not have that schematic, but on that schematic, this switch is shown as open, as normally open. And that sort of clicked the light on, and I figured out, okay, we got a problem with this chip. And now this chip is on its way. Another one of these components that's on its way. I've got now quite a few for this radio. It's in the mail. I've ordered it, and I'm going to replace this chip. But in the meantime, I can actually manually make these contacts. Think about it. If I remove this chip from the radio, right, I will have this thing floating. I will have no microprocessor activated mute function. So this can't operate in accordance with the microprocessor's instruction, but I can still short out. I can manually connect whichever one I want. If I put a little wire jumper to any one of these, 9, 2, and 3, and 4, I will get FM. If I jumper it to, 1, I will get AM. And if I jumper it to 6, I will get the auxiliary input. So I can actually do that, and that's why I put a socket on there so that I can play with it, make sure this is working until I receive the actual chip. And the chips that I've ordered are actually a CD4066, which I believe will perform the same function. It's not from the same manufacturer, but I believe it works. So we shall see, but I think I've solved the problem, and this thing was driving me nuts. It was driving me nuts because I wasn't reading the schematic properly. I was not reading it properly. The other thing that you'll find is this is 8 volts coming in here, right? Plus 8 volts. There's 8 volts. This 8 volts goes to this side of this capacitor. When you hit this button, when you activate mute, this 8 volts comes through here and goes to this end of this capacitor. So you've got a capacitor that's an electrolytic, it's polarized, and suddenly you're feeding 8 volts to a capacitor that's got 8 volts on the other side. I was going in circles, almost as much as the charge is on this bloody capacitor. So it drove me crazy. I think I finally figured it out, but that's why this week has not really gone as I'd expected, for the reasons that I've just, well, tried to describe to you, and also the fact that a lot of stuff is on its way. So let's go back here and I'll show you how I can manually connect these across. This is the setup that I've got here. I've got this little jumper wire, and it's connected into pin number 2. Number 2, 3, and 9 are the outputs from that selector, okay? So it's in number 2, I could put it on 3, I could put it on 9, it would make no difference. And then I've got it fitted into pin number 4. Now number 4 is where the FM is coming in. So I've got it on FM, and I'm going to put the volume up. Brilliant. And this thing has got a lot of volume now. No problems with volume there, okay? And look at that, that's the audio output DC voltage, just about 0. Now, if I select medium wave, first of all, as you can see, when I push it in, I get my 8 volts. So that shows us that the muting function of the front switches, you know, with that little contact switch they've got in the front there, that's still operational. So you won't get the thump when you change channels, okay? But this thing is expecting to be getting FM. And there is no FM because I've selected medium wave. So now, to get medium wave, I've got to change that from 4 to, what is it, 1. Okay, let's try that. That's on 2. Take it from 4 and put it on 1. Put the volume up. It's getting medium wave, although there's nothing there. But as you can see again, we've got nothing, as far as DC is concerned, we've got nothing there. I'm going to put the mini whip on. Volume is very, very high. Let me try and tune this. Just going to move the pre-selector because my improvised belt tension is not working. There's our, that's our medium wave, because I've selected AM over there. And then of course, if I wanted to take the input from the external, I would take that from, what is that, 1? I'd take it from 1 to 8. So I would just put it to 8 there. So what we've got here is we've got this thing working by replacing the function of the switch, of that switching IC, which is obviously not the ideal. But as soon as I get that IC, I'll be able to fit that in there, confirm that everything works without any limited volume and without the muting function giving us any hassles. What else am I waiting for? I spend my life waiting. I'm also waiting for the belt, the new belt that I've ordered, because the improvised version I have here is just temporary. So that should arrive soon. When I say soon, who knows? It'll arrive. And then, of course, I'm waiting for the speaker surround as well. As you can see, it's getting more and more broken up as I use it, because this thing moves backwards and forwards. That stuff just falls out. I'll leave it there for now. But that should arrive soon as well. And I'll be able to replace that. So we'll be able to fix the speaker, fix the pre-selector tuning, which is obviously required, and also fix the selector switch at the back there. I know that my FM is working perfectly. It's working absolutely perfectly, so I don't think I'm going to be doing any aligning on the FM. I might tweak a bit just to see how it works, make sure that I know how to do it. There's something else here. This thing, I think, requires some pretty high frequencies for the alignment. I seem to recall seeing 54 megahertz here somewhere. I don't have any way of of generating a 54 megahertz signal, so I might have to skip that part of it. But then, of course, there's the AM. I've noticed something. Maybe it's got to do with the preselector, but I have noticed that the shortwave is a little bit deaf. It's not as good as it should be. The medium wave seems to be okay. Long wave seems to be okay. But the shortwave seems a bit deaf, so I might have to do some alignment there. I believe there's intermediate frequencies, more than one there, so there's probably still a lot to be done. And that, my friends, is about all I can do on this for now, until I receive everything and am then able to sort of take up this project and finish it, because I do want to add this to the collection. I'm actually starting to like this baby. I am. I like the idea of inputting the frequencies you need. There's the pre-select stations that you can put on here. I've been playing with that. I've cleaned this part of it up so far. And yeah, there are a few things to do. There's some light bulbs to change, but I've got some spares. So there's a lot to be done here. And it's a good thing, because I enjoy this radio now, since I've discovered what's wrong with the bloody mute, which left me speechless. So once again, thank you for your company. Sorry that progress couldn't have been faster on this one, but thank you for your company, and I hope you've enjoyed that. If you have, click like, share, subscribe, and all that jazz. And if you want to support the channel directly, please do so on Patreon. Thanks for watching. Bye for now, and stay safe.